Вот нет. Вот нет. Да, вот тебе говорю. Остался с носом. Со своим, с чужим носом остался, что ли? Нормально.
At the time of the launch, it had the largest primary mirror ever sent into space, and it also had a 96 megapixel camera to process the light.
И что еще хотел возразить, хотел сказать, наверное, простите. Вчера ничем. Круто.
Хотите начать зарабатывать, продавая товары на Валберес или Озон? Тогда приходите на нашу трехдневную конференцию, которая пройдет 5, 6, 7.
The Kepler telescope was built for one purpose, to look at a certain patch in the Milky Way in search of exoplanets. The exoplanet hunter observed over hundreds of thousands of stars and
Я все равно
discovered...
ничего не понимаю. Я деньги не понимаю, где, как они существуют, я не понимаю. Купил траву, да, не понимаю, как вот из ничего сделать деньги. Как сделать услугу, да, как сделать товар, непонятно. Не понимаю, ничего. Что им надо, я не понимаю. Им это же мы, это же я про себя говорю, мне что надо. Правильно? Так выходит, да? То есть как бы это я тебя понял, да. Непонятно, согласен ведь, да. Нет, ну да, понял. Да. Вообще, да. Как дурак, я тоже чувствую себя как, что-то выходит, как гигант, да. Где там аппликация этой штуки?
discovered thousands of exoplanets during its lifetime. Launched in 2009, as part of NASA's Discovery program, Kepler's job was to constantly scan a fixed patch of sky within our Milky Way galaxy to find planetary systems. At the time of the launch, it had the largest primary mirror ever sent into space, and it also had a 96-megapixel camera to process the light. Astronomers were interested in finding out just how many stars have planets orbiting around them, and how many of these extrasolar planets or exoplanets have conditions that are suitable for life to develop. In its 9 years in space, Kepler observed 530,536 stars and confirmed the existence of 2,662.
Смотри, и это все равно, вот ты посмотри, вот это деньги. Какую-то мишку возьмут, какой-то возьмут, нет, понимаешь? Это деньги, понимаешь? Ну да. То есть, ну да, понимают. То есть, да, соображаешь.
New exoplanets. These exoplanets are unlike anything we've ever seen in our solar system before. Most of them are significantly bigger than Earth and orbiting so close to their stars that they complete one revolution every several days. And there are some very strange work. What of them are these exoplanets? 1,662 new exoplanets. These exoplanets are unlike anything we've ever seen in our solar system before. Most of them are significantly bigger than Earth and orbiting so close to their stars that they complete one revolution every several days. And there are some very strange worlds. Some have star-facing sides with temperatures that can melt iron, and have entire hemispheres covered with oceans of liquid molten rock. Other exoplanets the size of Jupiter orbit not one but two stars. If you're standing on the surface of one of these planets, you'll be able to see a binary sunset. But Kepler's legacy is that it successfully found Earth-sized worlds orbiting at a safe distance from their host stars inside what's known as the habitable zone, or Goldilocks zone. This is where the temperatures are warm enough for water to condense on their surfaces, but not so cold that it will just freeze up entirely. Although being in this zone doesn't guarantee the existence of life, the presence of water is significant and the foundation of life as we know it. One such exoplanet discovered by Kepler that has recently generated excitement among researchers is called K2-18b. In September 2019, two scientific teams independently announced that they found signs of liquid water in the planet's atmosphere. Situated 124 light-years away from Earth, K2-18b is about 8 times the mass of Earth and 3 times of Earth. K2-18b is about 8 times the mass of Earth and 3 times as big. It orbits a main sequence red dwarf star called K2-18. A red dwarf star is the smallest, coolest star and by far the most common type of star in the Milky Way. According to Kepler's data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in the Goldilocks zone, at least in our neighborhood. To Kepler's data, astronomers estimate that 6% of red dwarf stars have an Earth-sized planet in the Goldilocks zone, at least in our neighborhood.
Ну да, понимаю. Вот вы знаете, про потребности людей вы знаете. Смотри, ты знаешь, что ты школьный учитель с опытом. Можешь репетировать, можешь даже, да, начать там, да, как-то похожие на себя какие-то дела. Ну, понимаю там тебя. Да, типа того. Ну, да. Это уже, я не знаю, или вообще просто бизнесом каким-нибудь там, просто. Торговкой, там, не знаю, прочечной какой-нибудь, я не знаю. То есть, ну да. То есть вы счастливее, чем я, ну ладно.
Innovations to the world means solving a lot of problems. And you're really, really good at solving problems. Imagine a world where every problem you solve could serve as the foundation for a solution to the next. We're working to build a world where every line of code written was accessible not just to you, but to developers everywhere. Introducing Orbs from Circle CI, a configuration package manager built just for CI. Now you can reuse and scale bundles of config across teams and projects to keep the needle moving forward, instead of solving the same problem over and over again. Orbs from Circle CI.
To find water on the surface of one such planet is a landmark discovery in the search for potentially habitable alien worlds. K218b is also the first planet with water out of all of the exoplanets discovered by Kepler in the habitable zone of stars. Kepler first discovered the planet in 2015, and since then its composition has been studied using other telescopes, like the Spitzer and Hubble Space Telescope. Kepler mainly used what's known as the transit method for exoplanet hunting. It essentially means that if a planet passes in front of a star, the light from the star dims slightly, and that's how we can tell that there's a planet there. The level of dimming and how long it lasts gives us important information about the size and orbit of the planet. However, detecting the transit of an extrasolar planet is very challenging. For example, the diameter of Earth is only 1/109th of that of the Sun. So, for an outside observer of the solar system, the passage of Earth would dim the output of the Sun by only 0.008%. Kepler's cameras had to be sensitive enough to detect this minute change in the luminosity. Using the same method way back in 2014, Kepler first found a potentially habitable exoplanet. Kepler 186f ignited the imaginations of space nerds everywhere when NASA announced its discovery. Now a new study indicates the exoplanet, 500 light-years away, may also have seasons and a climate similar to our own. New research out of Georgia Tech University has analyzed the planet's spin and axial tilt and found that its tilt is stable like Earth's, which makes it likely that Kepler 186f also has is stable like Earth. Has analyzed the planet's spin and axial tilt and found that its tilt is stable like Earth's, which makes it likely that Kepler 186f also has regular seasons and a stable climate. Similar research on the massive Kepler database is going on in research universities all across the world. In fact, in recent years, previous Kepler findings that were rejected as potential Earth-sized exoplanets due to algorithmic error are getting rediscovered. These false positives are now slowly being reanalyzed in conjunction with data from other telescopes. One such planet is Kepler 1649c. In mid-2020, while combing through old Kepler data and matching it against new data from the Transiting Exoplanet Survey Satellite, or TESS, astronomers confirmed the existence of another exoplanet with very favorable conditions for life. Kepler 1649c, located 300 light-years from Earth, is very similar to Earth in size and estimated temperature. This newly revealed world is only 1.06 times larger than our own planet. Also, the amount of starlight it receives from its host 6 times estimated temperature. This newly revealed world is only 1.06 times larger than our own planet. Also, the amount of starlight it receives from its host star, which is also a red dwarf, is 75% of the amount of light Earth receives from our Sun, meaning the exoplanet's temperature may be similar to our planet's as well. Kepler 1649c provides yet another example of an Earth-sized planet in the habitable zone of a red dwarf star. But before we get ahead of ourselves, it's important to note that out of the 2,662 exoplanets identified by Kepler, only 16 of them lie inside the Goldilocks zone. And out of these 16, some of these planets are tidally locked with their parent stars, meaning that only one hemisphere of the planet faces the star, and this is not ideal for life. Others are more like a smaller version of Neptune than a larger version of Earth, and planets similar to Neptune are expected to have a significant envelope of hydrogen surrounding any layer of water on the surface, with a planetary core of rock and iron. If the hydrogen envelope is too thick, the temperature and pressure of the water layer beneath would be far too great to support life. On top of all of this, despite being cooler, red dwarf stars tend to be more active than Sun-like stars. Thus, the planets may be exposed to higher quantities of damaging ultraviolet radiation than what we're used to here on Earth. Because of this, surface temperatures can range between -100 and 116 degrees Fahrenheit, or -73 to 47 degrees Celsius. That means the surface could, on average, be colder than Antarctica, or hotter than Earth's most blistering deserts. Unfortunately, we just don't have the technological know-how to study the composition and atmospheres of these alien worlds and comprehensively answer all these questions yet. But don't despair. Based on the statistical analysis of all the Kepler observations, astronomers now estimate that 1 in 5 stars like the Sun have planets about the size of Earth, and a surface temperature conducive to life. Given that about 20% of stars are sun-like in our galaxy, that amounts to several billions of potential habitable Earth-like planets just in our Milky Way alone. Kepler not only focused its efforts in finding potentially habitable planets, in fact the bulk of its discoveries were strange worlds not suitable for life, but fascinating nonetheless, like the gas giants, planets composed mostly of gases such as hydrogen and helium with a relatively small rocky core, also known as hot Jupiters. These planets orbit extremely close to their parent stars and...
So, you think Planet 9 exists with 99.8% probability?
Something like that.
You think Planet 9 exists with 99.8% probability?
Something like that. Yeah, maybe I'll push it high. 99.9% probability.
It's just wishful thinking. It is. I mean, if you're that sure, find it.
In the farthest reaches of our solar system, way past Neptune and Pluto, a 9th planet may be lurking. It's predicted to have a mass 5 times that of Earth, and to orbit once every 10,000 years on a highly elliptical, inclined orbit. So why do some scientists suspect that such a strange object exists? That's what I've come to Caltech to find out.
Would you like to do your work? You know, I usually do it wherever. Wherever I have a couple of minutes of free time, I just do it. So this is where a lot of it gets done. My name is Konstantin Vitigan. I am a professor of planetary science at Caltech. And I do all kinds of astrophysics-y planetary studies, including stuff about Planet 9. These are variable transformations. I'll tell you where the Planet 9 boundary lies. It's like that. So everything to the left of that is all Planet 9.
So, I'm here to find out about hidden planets, and how to find hidden planets with math.
Okay.
So, how do we do that? I mean, do you want to start at the beginning of this sort of endeavor, or do you want to jump into Planet 9? Where do you want to start?
Well, let's start at the beginning, because the beginning has a long and beautiful history to it. In its origins dates back to 1781, I believe, when Uranus was first discovered by Herschel. And when Herschel discovered Uranus, he immediately realized that the star that was slowly moving across the sky had actually been imaged many, many times before. And it was a matter of going back to old observations and kind of retracing the orbit that Uranus was following on the sky. And astronomers and mathematicians of the time immediately noticed that there was a problem with the orbit of this newly discovered planet. It was deviating from where it was supposed to be. But a French mathematician by the name of Urbain Le Verrier eventually did this beautiful and very complicated set of calculations that said, okay, if there is a planet there, right, in that part of the sky, then we can explain the anomalous motion of Uranus. And when once there was a mathematical prediction of where to look, astronomers were then able to discover Neptune with basically pinpoint accuracy.
How quickly did they find Neptune?
So this is a remarkable story. They found Neptune in one night because they knew exactly where to look.
There could be a 9th planet. There's a lot of space for a 9th planet in the outer solar system, but there's no good evidence for a 9th planet at the present time. And a particularly scary thing about the 9th planet is that a lot of people want to believe that there's a 9th planet. And we all know there's this huge psychological bias to the effect that if you want to believe something is true, you will find evidence, real or not, that it's true.
Everyone and their brother in the last 170 years have predicted planets beyond Neptune. But all of these theories have failed to date. I think that we, meaning myself and my collaborator / partner in crime, Mike Brown, are right. our understanding of the solar system has evolved dramatically in the last 20 years. We've discovered that there exists this one additional belt of icy debris called the Kuiper belt. Right? These are kind of big icy asteroids that are maybe the size of LA, floating around beyond Neptune.
Who's responsible for finding the Kuiper belt?
I found the Kuiper belt with my student, Jane Liu. We were looking for anything, actually, beyond the orbit of Saturn. So the puzzle in 1985, the puzzle was, why is it that the inner part of the solar system is full of asteroids and comets and all sorts kinds of things, planets, all this stuff, but then when you go beyond Saturn, there's Uranus, there's Neptune, and there's Pluto, and then that's it. Why would the outer solar system be so empty? It's a very simple question of the kind that I can understand. And the answer was, well, let's have a look. You know, maybe it's not really empty. Maybe it is, in which case that would be interesting, but maybe it's not. So we started a survey to find stuff beyond Saturn. And we did the survey for a long time, 5 years or something, 6 years, and found actually nothing for that whole time, including nothing just beyond Saturn where we expected to find stuff, until finally in 1992 we got this thing way out, and we could tell immediately it's way out, 45 AU, 50 AU, from the slow motion across the sky. We found this thing out there, what we call now the first identified Kuiper belt object. It's actually the second, because Pluto, what we from the slow motion, to tell immediately it's way out, 45 AU, 50 AU, from the slow motion across the sky. We found this thing out there, what we call now the first identified Kuiper belt object. It's actually the second, because Pluto was misidentified back in 1930 for all sorts of reasons connected with, because Pluto was misidentified back in 1930 for all sorts of reasons connected with sociology and propaganda and things like that. People wanted to find a planet, and so no matter what, Pluto must be a planet. So that process has continued. We have more than 2,000 of these objects now, so in 25 years, 2,000 of these things have been found. We think the population is vast. There's a billion things bigger than a kilometer across, maybe more, maybe a couple billion. It's some of the more distant objects that appear to some people to show this orbital alignment. A kilometer across, maybe more, maybe a couple billion. It's some of the more distant objects that appear to is vast. There's a billion things bigger than a kilometer across, maybe more, maybe a couple billion. It's some of the more distant objects that appear to some people to show a couple billion. It's some of the more distant objects that appear to some people to show this orbital alignment. And they have, in particular, a very large perihelion distance, so they never come close to the Sun, they never come close to even Neptune.
If you look at the most distant objects in this belt of debris called the Kuiper belt, all of their orbits kind of point into the same direction.
Is it possible that there are some going in the other direction and we just haven't found them? They're there.
Yeah, of course, that's a great question. Generically, when you search for objects in the night sky, there are always what are called observational biases. So you're always limited to finding objects only where you look. So this is a key question that you have to ask, right? Is it that we only found objects that are all pointing that way, right? Their orbits pointing that way, because we only looked there. The answer is that there is a chance that this is all a false alarm, okay? And that chance is 1 in 500. There are bodies that occasionally will swing out into other directions. It's more that overall, if you look at it, there is an overall tendency. So here, what we see is a pretty typical kind of simulation of the type that we do. We start the solar system in an initial kind of totally random state where all the objects are pointing everywhere. For scale, these pink circles here are Uranus and Neptune, and this long ellipse, this long pink ellipse is Planet 9. These blue guys, these blue orbits, are long period Kuiper belt objects, the ones that in the real solar system we see the clustering among, and these gold or greenish ellipses are the more short period, more proximate members of the Kuiper belt, which are not clustered at all. So it takes a long time, but about 2 billion years into the evolution of the solar system, you begin to see the fact that objects that are collinear with Planet 9 have all been scattered away, removed from the solar system dynamically, and the only kind of remaining members of the distant solar system are the objects that point the opposite way. Again, it's a remarkable gravitational signature, gravitational one-way sign, if you will, that something is confining these orbits, keeping them clustered, and pulling them all into the same plane.
You know, the experts, I think it was Scott Shepard and Chad Trujillo, who first noticed this alignment. They call it a 2.6 sigma result, which means that, you know, it doesn't really meet the threshold for acceptance. The scientific...
Would you be looking at 5 sigma? Is that...
I mean, the standard thing is 3 sigma, right? But half of all 3 sigma results are wrong, is what I always say, as an observer. So the more significance, the better. But 2.6 is not enough.
So even though these clusters of asteroid orbits in the Kuiper Belt provide the best evidence for Planet 9, there's a chance that further Kuiper Belt observations will find different, unclustered orbits. But regardless, there are 2 other solar system mysteries that could be explained by the existence of Planet 9. These properties of Planet 9, they seem like kind of nuts. Like a period of 10,000 years, that's not like any of the planets that we have found. So why would we have such a strange planet hanging out there?
Yeah, great question. Indeed, none of this is reminiscent of anything solar system, right? If you, for a second, ignore the period, right, and ask yourself about the mass of 5 Earth masses. We don't have anything in the solar system that's 5 Earth masses. We go from 1 to 17 when we go from Earth to Neptune. Is it wild? Actually, turns out this is the most common type of planet in the galaxy that we have discovered around other stars. It may be reversed. The fact that the solar system doesn't host a object which is 5 Earth masses closer to the sun is actually kind of weird. Indeed, 5 Earth masses, as it turns out, is kind of a standard outcome of planet formation. There are more wild things out there, okay? And this is really my favorite aspect of the Planet 9 hypothesis. It's the fact that Planet 9 actively flips orbits on their side. You should not expect to find objects in the solar system that are flipped on their side and are orbiting the sun perpendicular to the planets, and you should definitely not expect objects that are orbiting the solar system the wrong way, so to speak. Yet we find them, right? They exist in the Kuiper Belt. Right? And this has actually been a problem since before Planet 9 was even a thought. Planet 9 has this intriguing mode of dynamical evolution that it instills upon distant orbits, where it takes them and at the expense of kind of circularizing these distant objects, right, making their orbits less elliptical, flips them upside down and then makes them more elliptical again. It's a complicated dynamical evolution, and really at a detailed level you have to go to the computer simulations to understand how it works. But the key kind of product of the existence of Planet 9 is the expectation that such objects would exist, and we see them. And really, there isn't another kind of natural mechanism to generate these highly inclined bodies.
You know, you have the plane of most of the bodies, and then some of the bodies out there apparently have their orbits almost...
Хорошо. Все вообще просто замечательно. Круто. Животные. Интригующие. Что это такое? У меня друзья, что ли, такие? Нет, Ну, мне, ну и что? Что дальше? А это не важно. Ну, женский подход, типа того, да. Нет, нормально, значит. Ну нет, потому что... Ну да, значит, все не так, все хотелось. Ну вот это есть оно, да. Да. Блин, я так так никогда не делал. Я знаю его, что ли? Знакомый, может, брат или... На Лёписа похож, да? Не знаю. Эх, ма. Не страшно, что ли? Ладно. Нет, там, да. Да наоборот. Лукавство, конечно, да. Я не понимаю, ну, значит, вот я такой человек, что для меня жизнь игра, как бы, да. Это неправильно, но для вас не игра, конечно, да. Поэтому таких серьезных, с таким серьезным лицом в KFC кормите мопсов из них, из человека, ну да, понимаю, идиоты, просто имбецилы, то есть как сумасшедшие все, ненормальные. И это все за мой счет, то есть это меня не касается. Это просто так, по логике хотя бы даже. Проехать сюда, понял? Никто не будет вас лечить. Чем? Нет. Ну что теперь делать-то? Презумпция невиновности. Ничего страшного.